All right, so in the last video here, we're going to look at evolution in action. We're going to look at the evolution of horses, whales, and humans. So we're going to be looking at some fossil record stuff. Now, in this video, we have some videos that are embedded. I want you to watch them, all right? So they are kind of part of this video, but you'll need to obviously watch them on your own. So let's start with descent with modification. So this is something that we've already talked about, but just as a quick review, descent with modification describes a pattern of evolutionary change that we observe in the biosphere. One of the ways we do that is studying fossils in chronological order. And when we do that, we see that the older fossil-bearing rocks have fewer types of fossils with simpler structures, and younger rocks or more recent rocks typically contain a greater variety of fossils with more complex structures. So in order to explain that, one possible mechanism that we use is natural selection. All right. And in this week, we're going to cover horses, whales, and humans. So let's start with horses. So the first horse shows up around the Eocene in the organism that we have named Eohippus. And when we look at the major changes in the horse over time, the thing that seems to drive the change in the horse is the environmental changes. And things that we've seen in the fossil record include the body size has changed. It's gotten bigger. The limbs have gotten longer. Eohippus actually had multiple toes, where modern horses only have the one. The width of the teeth has changed. All right. The tooth length has gotten longer. And the loss of premolars and the replacement of those premolars with molars are all things that we see in the fossil record. Now, when we talk about what we're looking at, this is a pretty information-packed slide, so let's kind of take a minute and break it down. So Eohippus down here at the bottom, we usually find in the Eocene layers of rock. So here's the Eocene, here's the Eohippus skull. And we find that the front foot has 4 toes in Eohippus and Orohippus. The back foot has 3 toes, okay? And when we look at the teeth that we find, we see that they look like this from the side and from the top, so pretty short. And the overall jaw structure, you can see right there. All right, now, as we look at younger and younger rocks, we start to see changes. So in the Oligocene, we have Mesohippus. So 2 fossils later, still has, the overall shape of the skull is similar, but we find that there's only 3 toes, okay, on the front foot, where before there were 4. Still 3 toes on the back. The teeth are getting larger, and you can see that they're starting to get a little bit wider than they were down here at the beginning, okay. When we keep moving forward, we have Pliohippus, right? We'll go 1, 2 more. We've now gotten to where from 3 toes to 1 toe on both the front and the back, and we're starting to get this much longer tooth, all right? And then finally we have Equus, which is the modern horse, okay? And you can see that the tooth has gotten much longer than the ancestral horse. So we can see changes in the horses over time. Now, when we look at the fossil record, it's important that we understand that the fossils are a record of change. So in the case of the horse, we have a longer leg, all right, where, before they were about 0.4 meters, so, not even half a foot, to modern horses that are 1.6 meters, so that's like almost 4 or 5 feet, okay? The toes, they're shortened, okay? So, they were longer, and now they've drawn up, and in fact fused, so that we went from 3 toes to 1 toe. The teeth were enameled, but now we find that they are ridged. And when we look at all of these different changes in the horse, okay, we have to try to explain those. So one would be environmental stress. So the predator-prey relationship, as horses are, consumers, right? They're herbivores. So something probably chased around the ancestral horse and wanted to eat it. Its running style, the best way for it to, escape, required a certain running style. And obviously, the diet of the horse is going to influence changes and successful mutations or unsuccessful mutations as they are passed from, ancestor to offspring. Now, when we look at, Mesohippus to the modern horse, obviously it's Eohippus is even older, and there's even an ancestral horse before that. But for this slide, we're looking from Mesohippus to modern horse. You can see as the timeline changes, you can see structural changes that are occurring, like 3 toes down to 1. You can kind of see the toes draw upwards in Merychippus and, eventually disappear. The teeth, you can again see here is a fossilized tooth from I want to say Mesohippus, but don't quote me on that. And then here we have our modern horse, definitely much different tooth structure, right? Different diets. And when we look at structures and we look at functions, a lot of times what we want to look at is a comparison of how those things behave. So this is a pretty interesting look at galloping compared to the movement of a cheetah in a little bit slower motion. And you can see a lot of similarities, see some differences, all right? And when we're examining fossils, we are trying to explain the function, all right, based on the structure. So, that's another thing that we look at. So when we look at leg bones, we're trying to say, hey, how did they get around? We look at the toes, right? How did the foot interact with the ground? We look at teeth, all right? We're looking for, examples of their diet. So Eohippus may have had a similar diet to the koala bear, which eats leaves. Well, how do we know that? Well, we look at the teeth. So the teeth here and the teeth in the modern koala, very similar. So it stands to reason they probably have a similar diet. We look at the modern horse and the modern cow. They both eat grass, and we see that, again, common structures, common function. So the horse is a great example of how we can track the gradual change of an organism over time. Now, the second thing I want you to look at is whales. And I actually want you to watch this video. It does a really good job of explaining the evidence for the evolution of the whale. So watch this, all right, and then come back to the video and we'll keep going. The last thing we're going to look at in this video is human evolution. Now, we do want to know the major milestones of human evolution. So about 6 million years ago, we find ancestral primates that are what we call bipedal. So they're moving around on 2 feet. They're walking upright. 4 million years ago, we're still finding some bipedal adaptations, but also some tree climbing adaptations. 2.6 million years ago, we call the dawn of technology. That's when we find the earliest evidence of tools. About 800,000 years ago, we have the evidence for the use of fire. This is found in, caves and burnt logs and fire rings and that kind of thing. Between 800 and 200,000 years ago, the brain size in the fossils that we find is rapidly increasing. And about 12,000 years ago, we have the development of agriculture. Now, why are we talking about historical things about like fire and agriculture and, while we're talking about evolution? Well, just like the diet of the modern horse, right, is different from the diet of, the ancient horse, the diet has a lot to do with your day-to-day life. So when we start using fire, we start cooking our food, we actually need less brain space devoted to breaking down our food, which frees it up for other things. So, it makes sense that when we start using fire, all of a sudden brain sizes start to change. Diet impacts, all right, the quality of life and the success of a species, and the passing on of genes can be influenced by diet. So that's an important thing. Now, there is a website that's linked here that you can go and you can kind of look at all the different fossils that we find. They keep updating this thing. This is just a screenshot from when I made the original PowerPoint. lots of different fossils that have been found. We're going to look at Australopithecus. We're going to look at the Homo sapiens group. We're going to not really look at the Paranthropus group a lot, or the Ardipithecus group, but they are certainly fossils that are worth your consideration. Now, if we start here with a general timeline of human evolution, if we look at the picture here, okay, we're going to start with Australopithecus afarensis, and we're going to move this direction to today, all right? And we do find tools, starting with Homo habilis, and he is the first of the Homo species that we're going to look at. They're the Homo genus. So let's look at Australopithecus afarensis. This is a species that's commonly called Lucy. It's the name of the fossil that they found. Here she is compared to a modern human, so not nearly as big, but you can see some pretty striking similarities. We have the inward-facing femur, the pretty pronounced shoulder joints there, all right, but also definitely some differences, right? A much more primate-like rib cage than we have, so an ancient ancestor here. Now, they ran between 3.5 to almost 5 feet tall, somewhere around 100 pounds. And they were the fossil of Lucy was discovered in 1974, along with some footprints, which showed a group of these Australopithecus organisms kind of walking through this, I guess it was a mud flat that ended up fossilizing their footprints. Homo habilis, which dates from 2.4 to 1.4 million years ago, also around 3 to 4.5 feet, weighed about 70 pounds, much more, or much closer related to us, and is the first fossils that we find with evidence of tool use, was discovered in 1964. Homo erectus, which means upright man, about 1.89 million years ago to as early as 143,000 years ago are some of the fossils that we found. Much more like modern humans as far as their proportions are concerned, ran from 5 to 6 feet, 88 to 150 pounds, so a little bit more similar to modern humans. They had the hand axes, which are rocks that are chipped so that they can be used to smash things or cut things, which was a big deal. The most preserved fossil that we have is called the Turkana boy. It was discovered in 1891 in Java, China. And this is the first evidence of the human species that we find outside of Africa. It is a direct ancestor of Homo sapiens, so us. Now, something that you're probably very familiar with, that you've probably heard before, is the Neanderthal. And the species of Homo neanderthalensis ranged from about 400,000 to about 40,000 years ago. They ran from 5 to 5.5 feet or so, about 120 to 150 pounds. So very muscular, very strong, but kind of short. They're named for where they were discovered in 1829. And we have evidence from, where we found them, of hunting, of shelter building. They use complex tools. They may have buried their dead. And they even left behind art for us. Here's a pretty interesting video I want you to watch. I'm going to kind of mute it here and just point out a couple things. But cave art is a great example of, or is a great evidence for what ancient humans were doing. So watch this video. There was a picture in here I wanted to find. Yeah, there we go. So not just, representations of exactly what it's, but also some abstract things. These dots, nobody really knows what the dots are for. But anyway, watch this video, because art is one of the things that we that makes humans, human, right? It's one of those things that we recognize as a more human activity. So the idea that Neanderthals were, unintelligent is kind of outdated. That's not an accurate statement anymore. And, these are some of the cave arts that they have left behind. Now, Homo sapiens, modern humans, that's us. right? We have fossil record evidence of ourselves for about 300,000 years to present. You'll notice that that means we coexisted with the Neanderthals for a while. We have really large brains, modern skulls. We don't have those heavy jaws or the brow ridges of, the Neanderthals. And then Cro-Magnon is also included in this group, the Cro-Magnon man. There's no prognathism, this word right here, which means the jaw is extending out below the plane of the face. All right. So that's just a brief overview of some of the fossilized human ancestry remains that we have. Hopefully, you'll watch the art video and you'll watch the whale video. But that's just about it for this week. All right. So if you have any questions, let me know. I'll be glad to give you a hand.